Hey folks, welcome out there. You are at Mathline. I'm Ernie Roberts. I'm your host for this afternoon, and I am joined with the sidekick here, Gary Petco. He's a pretty good guy from Knox County Schools here, and enjoyed working together last Monday. We're going to come back for another round. But what we need you guys to do out there, and ladies, gentlemen, everybody, join in. Simply give us that call. We've got a number flashing up there at the lower third of your screen, 844-686-2378. Call us with some math questions, all right, math problems. We will love to work them out with you live here on the air, help you with your homework, and maybe send you to school with a smile tomorrow for your teacher to say, "Gee, good job." Yeah.
How can you not smile with math?
Hey, absolutely. It's so much fun. It is. And speaking of getting this fun started, folks, we have a problem of the day just for each of you. And here we go. Gary, read that one for them, okay?
Okay, it's a mean problem. If 9 is a mean proportional or geometric mean between 3 and a number, find the other number.
All right, so we've got to know what, I guess, a mean proportional is.
I know what it is.
And a geometric mean. So first things first, let's go through a little bit, because proportional leads me to think a proportion is involved,
as a
right?
ratio, yes.
And so we're going to make a couple of ratios going on here, but let's just go back to our sheet down here. There we go. And if we're talking about 9 being the mean proportional or geometric mean, let's just go a few little notes over here. First of all, I'm going to put, or try to build a proportion. And I'm going to put an A and a B here.
Right.
And back in the olden days and in the new days, whatever, these are called extremes of your proportion, all right? Some books still impress that and get through that. And the other ones here are a mean, okay? Now, this is not arithmetic means, where you add two numbers together and divide by 2. That's a little bit different on this one, folks. What we're going to do here is we're going to say on this proportional, we're going to call it X. They're both the same. We don't know what they are. But we are going to figure out, hopefully, how all 4 of these little pieces relate. Because you know what the story is, right? You cross multiply, and the product of the means equals the product of the extremes. And I got x times x, which is x squared, equaling to a times b. So you say, well, Ernie, what's all that got to do with our problem of the day? We've got some numbers here. We've got to figure out where to put them. Absolutely. So, Gary, 9 is the mean proportional. What is that? Which variable am I taking on here?
Well, 9 is, and I'm reading that left to right. So is means equal to me.
That sounds good, yeah.
9 is my x squared.
So your x value equals to 9. And our A is going to be, let's just call it 3. It looks like we're looking for B this time.
That's right.
Now, I'm going to say something here. If we had used, let's chosen A and B and said, let's find X, it would be pretty easy. You'd multiply, what, 4 times 9?
4 times 9.
Then take the square root. You would be home free. So it's another way we can look at it here is this X is equal to the square root of this A times B. But I think in the case that we've got here, it's going to be easier to work it out with the x squared part.
I'd agree with you.
Because we're looking for that missing link there. So let's go for it. So on our proportion here, we decided A is going to be 3.
Yes.
So we'll put a 3 underneath. Here we go with X, 9.
Then B is just the other number.
And B is there we're going. So my friends, we're going to cross multiply. So those of you, by the way, some of y'all on Facebook are really doing a good job on these things. Sharon, Mark, Melody, and Vicki all have responded to our problem today, which got kind of posted a little bit late today, but that's okay. We're going to be fine. I do remind you that we will be posting tonight's problem of the day tomorrow. No, tomorrow's problem of the day tonight.
That's right.
So after the show. I'll get it straight. So what's the question here? We're going to look for B. Some of you are going like, whoa, he just went off in a lot of different ways here. So cross multiply, my friends, and it's 3 times B. Cross multiply the other way. We've got 9 times 9. 9 times 9, I think, gives us 81, correct?
Still is.
It still equals 81. It hadn't changed, is it? Those are those basic multiplication facts.
Yes.
And that's another reason why, folks, it's kind of nice if you can just hit that and go rather than having to worry about dinkling on the calculator. Now, we'll do some quick division here. We're going to divide 3 into 81. I know it's going to go evenly because the digits, the sum of those digits add up to 9, which is divisible by 3. And dividing it out, I have B equaling to, looks like 27.
That's right.
Are you good on that? Sound good? And again, check real quickly. Let's go back to our, we said mention geometric mean, so let's go back and put in the x equals the square root of, and if we go 3 times 27, basically we're saying that x is equal to, and we're going to look at the primary thing here, although we could go plus or minus. We're going to have the square root of what, 81? And that would give us back to the 9, since that's what we're looking for. And also, you have folks here, so you say, well, what about negative 9? Well, with the x squared involved, yes, we could do that. We could have a plus or minus situation. This is not necessarily talking about a piece of a triangle or a part of a line segment length or something. But nonetheless, there we go.
Now, Ernie, what am I doing incorrect if I said my other number is 15? 3 and 15.
Yeah, we had a couple of people on Facebook that said it's 15. And let's take a look at that. What happened there? I believe they were thinking arithmetic mean.
Arithmetic, well, the mean that we normally think of.
Yeah, and that is a mean, but it's just not where we are here. We're talking about the geometric mean proportional, and that is set up in this nice little manner there. Right. So what this would give us, that would be what, 18 over 2, which gives us 9. That is a 9, but unfortunately the 15 was, it's the answer to the arithmetic mean if we do that. So anyway, folks, there you have it. And problem of the day, hopefully solved. It's going to be a ratio and proportion week here on Mathline for problems of the day. We're going to be doing all sorts of things with ratios and stuff. So get your thinking caps on there. Going to have some fun. I mean, say probably some scale factors, some other stuff there. And you just don't want to be a part of it, okay? Speaking of being a part of it, let's get those phones ringing. 844-686-2378. Got operator waiting to take care of you. Got 2 of us here that would love to help you with your math homework, my friends out there. So don't miss out. Don't miss out.
Give it to us, yes.
Give it to us, and we would love to see it. Well, in the meantime, get you primed again. We thought this geometric mean would get you started. Let's take a look at another problem, Gary, together here. All
right.
See what we got there. Pull that one down.
Oh,
look at some stuff about rectangles here. Some of us like those rectangles. We live in a rectangular world. So let's take a look at this one here. It says, find the dimensions of a rectangle whose perimeter is 40. Oh, we got a little if there, don't we?
If.
That if always messes up some of us. If the length is what? 6 more than the width. Now, when I'm thinking of perimeter, you correct me here when I'm wrong, because sometimes I do mess up. 2 lengths plus 2 widths will get us to the perimeter, right?
Distance.
That's a good formula.
Each one of the sides added.
So in other words, we're going to cut all around here, and we're going to go ahead and we're going to call this length and we'll call this width. So we got 2 of them, and we've got 2 of these. So there's your figure. That's how it works. Now, what information do we know? We have figured out P, got the perimeter rolling, which is 40. We have length. Well, we sort of know length.
It's sort of in relationship to the width.
Yeah. So let's make a little note over here. We know the length is what? And we know W will be our width. So what about the length? What is it, Gary?
Well, I guess I'm just trying, I go from general to, I'm from specific to general. If the length, if the width was 2, then the length is 6 more than that would be 8. So it looks like it's whatever the width is plus 6. That would be plus 6.
We start with an easy little moment there,
Yeah.
right? Now don't go out and tell everybody that the answer is 8. No, that's not. We aren't there yet. Okay, we're going to have to figure that out. But we are going to say this is the width plus 6. All right. Now let me tell you, why do we use L and W? Because they're the starting letters of length and width. So folks, sometimes you get nervous about when you use variables. That's a nice way to go with it. Usually we use the first letter of those things so they stand for words that make sense, hopefully, to each of you as we work through them, all right? So in this case, I'm going to put it on the picture because I'm kind of a picturesque type person here. And if that's W plus 6, that's W plus 6 at the top, isn't it?
If that's a rectangle, it sure is.
Yeah, and that kind of goes back to right over here. Got 2 of them, all right? Over here, how about a W and a W right there? Because you didn't change anything on those. Yeah. And by the way, for those of you who like to know things, yeah, we got 4 right angles in there. I think that's kind of important to know. It's a rectangle, all right? So just a little teaching moment there, as I like to call it. So, Gary, what do you think?
It looks like we can create an equation with just one variable.
I like that. All W's.
That's right.
Now, some of you go, where did L go? Well, L got replaced by W plus 6. A little substitution moment there. So let's see what we've got here. You said we're going to add all 4 sides together. I like that. Now some of you say, well, what about that formula? Well, just hang on.
It works.
It works too. So let's go with our W plus 6. Another W. Does everybody see something there? That's the 2 L's, and there's the 2 W's. We're just stretching it out for you guys. How many W's altogether? I count 1, 2, 3, 4.
4 of them.
Some people say, that's nice. I get to, yeah. And how do we write that? We just put a 4W there, okay? And we're going to add these two together. And you say, Ernie, why are you doing that? Because we want to make them equal to how much, everybody? And Gary?
40.
40.
That's what we told the perimeter was.
That's what we were told. So we get to play with that 40. Now, I think it's easy to figure this one out. Let's lose this 12 here. How about it? Subtract it. If we subtract it from the left side, we got to subtract it from the
right side. Got to be equal.
And some of you are going like, oh, this looks like algebra I learned a long time ago or just recently and such. Probably some of you doing these kind of problems right now in class.
A little two-step equation right now.
4W equaling to 28. I think we can divide that evenly because we know our multiplication facts. And that's going to give us W equals to 7. So now, Gary, it's an ACT question. And they asked to find the width. Well, we got it, right?
We did.
But if they ask to find the length, what are we going to do?
Well, good thing we wrote it the length in terms of the width.
We did. We got it right over there. That L equals W plus 6, giving us a take care of me, take care, because we're actually finding both dimensions here. So what do we got? What do we, 7? Add the 6. And I'm thinking we've got 13. We didn't really say what units these were, but they are not square units. All right, that's area.
That's
so
area.
This is all about perimeter. So everything is just in simply linear lengths, those nice inches or feet or meters, centimeters, all those good things. No squaring here. And by the way, that is our length. So the dimensions, 7 and 13.
Which we could double check.
Oh, yeah.
See, it all adds
Let's
up to
check
40.
it. Put a 7 in there. 2 of them. 3 of them, 4 of them, my goodness. And make a 13 happen and a 13 happen here. I think those add up to 20 and double it. We've got 40.
It worked.
Easy way out of there. All right, folks, we're going to try to make it easy for you today, all right? But you've got to give us a call, all right? 844-686-2378. That's our lucky number. And again, give us a call. We'll take care of your math problems here together. And Gary Petco with me from Knox County Schools here. And I am excited to have him on the show today. And he'll be back again tomorrow, hopefully.
Absolutely.
We're planning on
Absolutely will be.
So, but give us a call today because we're here to help you out. We got about another 15 more minutes to go on the show, and we really want to take good care of you. And in the meantime, I understand we have, I think, another Hey Mathline waiting. So let's go there, guys.
Hey Mathline, I'm Jared from Powell High School in Tennessee. Could you please solve this equation? -4 times the absolute value of 3y plus 6 equals -24.
Wow. Gary, what's that equation again? That looks kind of crazy.
That's got a lot of operations in there.
And those little bars, those mean what?
Absolute value.
Absolute value. And you know what? I know some students who look at that and they see those negatives and they start thinking, no, we can't do that because we're not supposed to have negative numbers along this, right? But let's take a look at this thing. We're going to work it out here together. And then, folks, while we're working on this, give us some calls, all right? And let us help you out here also. Storyline. Where do you start on one like this? You did Algebra 2 a lot,
Absolutely.
and Pre-Calculus and Algebra 1. So.
Loved every bit of that. I'm just going to undo what was done to the variable. So I kind of do my order of operations backwards. And I see that grouping symbol, and I've got to get the grouping symbols by itself. So everything inside this grouping symbol by itself. I need to get rid of that
so we really don't want to play the distributed property game here.
Absolutely not.
No, this is where this is one of those things, folks, where you want to take care of this thing, and you say, well, what are we going to do, Ernie, with the -4? You're talking about it, right? Are we going to subtract it? Are we going to add it? What are we going to do?
Do that inverse operation. It's
hooked in by multiplication.
That's right.
So we're going to divide by the -4, both sides. So Jared, here you go. We got things going here. Jared from Powell High School today with us. And lose the -4s, but don't lose the bars.
No.
The absolute value bars are still hanging on. And by the way, folks, we 3y plus 6, that's, it's just a variable, all right? So don't get excited that it wasn't an x or an n. We always have our little pet peeves. So any variable works, okay? Now, what happens here, though, all of a sudden, good news is we have a
positive.
Now it looks like those kind of things they have in Algebra 1, okay? and pre-algebra even nowadays. I guess they're doing some of these. So we are going to need to set up not one, but two equations, because we got two solutions coming our way here. And you got to trust us on this. So this value in here, this whatever. Expression, I like that word. Yeah, there we go. Is possibly going to give us a positive 6, but it could also give us a negative 6. So let's take two samples here, all right? And I'm going to put one right here. I should have put one there for your side. Y plus 6. By the way, we never change anything inside the expression part. That's got to stay constant. Equaling to 6. The other side of the coin, we got 3y plus 6 equaling, it could be a negative 6, we decided. Because the absolute value means how far away a value is from 0. So 6 is 6 units away, but negative 6 is also 6 units away. So that absolute value, think about that as being the case. Because some people look at absolute value and think, oh, just changing signs. No, it's always dealing with how far away. It's a distance. It's always a positive value when you isolate those bars finally. Okay? So let's go with it. Easy equations, everybody, right? Everybody like that?
Like
I like
two-step equations like the previous problem.
You know, it's funny when you look at all these math problems and people ask, now, why do we do that? They all build. Absolutely. They build in different ways. So we were doing a rectangle, and now we're doing a little absolute value. And you know what we're going to do? We're going to even put it on the graph here in just a minute.
Absolutely.
Are we brave or what here? I tell you. All right, so let's subtract 6, because that's the way it's done. It's going to be the way it's done over here too. I'm getting 3y equals 0. Enter panic attack on some of my students because they see a 0 and they decide, oh, the answer's 3. No, it's negative 3. No, it's, I don't know, it's no answer. You know, that you get all these things. But really, we're just dividing 3 into nothing, and nothing stays nothing, right?
Or 3 times something has to equal 0.
0, and that something must be
0.
0. So why is 0? Why is it? 0 is a good answer, and we'll even get to see it there in just a second. How about it? Let's do the same thing over here. Let's subtract our 6. And what do we have? We have 3y equaling to negative 12. Let's divide again. Okay, so we're going to divide these out. We're going to divide 3 into negative 12. This time, got to watch your signs, right?
Correct.
And we're going to get y equaling to
negative 4.
Negative 4. So we've got two answers. Now, let me and you're ready to caution with me on this. Dear friends, do not, repeat, do not make that an ordered pair. No. Okay, it's not 0, negative 4. There are two answers here, okay? They're basically y equals 0 or negative 4. Both are good answers. Now, we mentioned something about the calculator, all right? So, well, let's go ahead and check these while we're at it, okay? What we've got here, since we've got the screen up. Let's go back to the beginning. It's a good place to start, isn't it?
Substitute a 0 in there for y.
Put a 0 in for our y, and we got a plus 6. And the idea, we should get a negative 24 out of that, okay? So the question is, do we equal negative 24? Well, 3 times 0, that's easy.
0.
Don't put a 3 down there, folks.
I got that.
Yeah, 0 plus 6, which is 6. Times negative 4, absolutely. Now, why did I say, we don't change signs there, do we?
No, because 6 is just 6 units from 0.
Absolutely. So negative 24 does equal negative 24. We check. Life is good, all right? Over here, let's make sure life is good again. We'll take 3 times negative 4 with an absolute value, and we'll put a negative 4 out there. Boy, that's a lot of minus 4s, isn't it?
That's a negative 4 all over the place.
Oh, and then we're going to add 6, put those bars back in, and hopefully we're going to come back up with negative 24. So the important thing is what's going on inside the bars. And what do we get there?
So we've got a negative 12 plus a 6. That's a negative 6.
All right, but this time we're looking at absolute value, right?
Right, I'm saying how far is negative 6 from 0.
So that's good. Because we're still saying what? Negative 4 times 6,
correct,
which is going to give us a negative 24 out of that. And so they check out. Check out pretty good.
Algebraically, we got it.
And there we go. Now, folks, give us a call here. And we're going to show you one more thing with this problem. But give us a call because we want to hear from you. And Gary's given his time to come down and hang out with us today. We want to hear from you guys
Absolutely.
out there.
All you students from Knox County Schools and around.
Even over. Some of you adults. We have adults call in a lot of times too. 686-2378. But, you know, we are so good and gung-ho about using technology, and this is a place where we can use our technology. So I'm going to do this. Can we go back just one time to the question here? Yeah. We're going to start from here.
Okay.
Because we know the answer's checked here. But we're going to go back to here, And we're going to pick up, and we could do it with the -4 and the -24,
could.
but it's a wide range. Let's go ahead and trust ourselves on this.
Okay.
So let's go y equals, and we're going to go graphing calculator now. And there's a thing called absolute value, friends, and it's under that lovely math key. Everybody goes, oh my goodness, Ernie, where'd all that come from? Well, there are a lot of things the calculator can do, and that's just one page of information. So let's go over to num, right, which stands for numbers, right? And we're going to look, ABS, that's not what you have good abs after you've worked out all day long or anything. This is the absolute value. So let's put it right there. Oh my goodness, there are the bars waiting for us to insert. And we won't use 3x. We won't use 3y, excuse me. We'll just use 3x, all right? Because that makes it a little bit easier to figure out what's going on. Remember what I said at the beginning, these variables are just that. They're standing for numbers. So here we go. And you say, Ernie, what else are you going to do? I'm going to say that's nice. And let's go to another one. Gary, what should I put on the next one? Like
Well,
y equals.
where is it equal to 6?
Okay, so what we're going to do, dear friends out there, some of you are going like, what are they doing? Well, we're going to show you. Are we going to show them?
Yes, let's do it.
Drum roll time, hero. Bring, bring, bring. And there's the blue. There goes the red. And folks, where they cross, here and here, are our magic values.
So it's crossing it twice.
It's crossing twice. Now keep in mind, forget x and y from our problem. Our problem could have just easily been 3x plus 6, all right? As much inside that bracket as it was a y. This is the variable. So what we want to do, and I'm going to call upon the trace, but we've also called upon the grid. How far over did we go? Looks like -4. Does that sound familiar? That's one of the points we found. Then we will go up to the 6. There's an ordered pair that you could talk about where they intersect.
Right.
Now, over this way, we said 0. There's the magic right there. And those of you who know I love trace, so let's put it, there it is. And see what happens at -4. We come up with a 6. So there's a graphic check. The easy way to see where do those intersect, that's the solution.
Visualizing equality.
Yeah. And again, you say, Ernie, where did you get those again? So let's go back to our little page here. All right, let's go back to it here. A little moment of education time here. We can leave the calculator and go back to the problem page. Go right back down here. There we go. Thank you, Joseph. Doing a great job. He's our new director, by the way, folks. We're glad to have him with us, and so far doing a great job today. Now, what have we got going here? We have this amount. That's where we put it in there. We kept the bars, so we put the whole left side of the equation in there. And then we put what? The whole right side of the equation in for another y equals. And then we see where do they overlap. And by the way, notice they overlapped 2 spots, which is what we got. Cranking it out by hand. And by the way, it's advisable to know how to do both. Okay, I think you see the physical representation using the calculator, and then you get to their
Algebraic.
All right. So good stuff there. All right. So absolute value, ways to do it. That's why 2 of us are here sometimes, because we can pull out some different ideas from each other as different ways to solve these things. Now, we're getting close to the end of the show, and we still want to remind you folks who are dealing with us on Facebook, let's go there. Can we see the ad for Facebook or our page there? Like us, love us, share us.
Stream us.
And stream us. When we get to the old YouTube stuff, we are streaming today, so those of you who didn't get to see the show, you can always see it. There it is. Wow, that's fast. Subscribe to www.youtube.com/Mathline. Now, we go back to Facebook just a second. There is a little subtle difference there, all right? When you like us at www.facebook.com, it's /Mathline online. And of course, while we're on the air, we'd love for you to use that little number, that 844-we'll get it right, 844-686-2378. That's the magic moment. It is toll free. It doesn't cost anything. We're free for helping you. That's what we're here for, what we like to do. We'll also teach you a little bit of math, even if you don't want our help today, but we will give you a little bit of math going along with the run there. But again, sharing us on Facebook, we want to get those numbers up. We know a lot of our adult groups watch that. Don't forget Twitter. We also are on Twitter. You can find us there. And we're working on Instagram for you younger folks, all right? And we want to get it there. By the way, we're all over the place, Gary. Middle Tennessee, Eastern Tennessee, Southeast Kentucky, Western North Carolina, Western Virginia. Not West Virginia, but Western Virginia. But you know what? With that YouTube streaming, guess what?
It's all over the place.
Anytime, any place you want us, all right? And we want you to take care of us. Give us some calls. Let us know what's going on with you. And also, school year is starting. Now, some are out on election day tomorrow, aren't they?
It is. Yeah, a lot of people are.
Election day. By the way, you adults and students who are over 18 and over, be sure you've made your vote cast in those places where they are having elections tomorrow. So
right.
we got some big ones here in Knox County and this area. So that's why the schools are not meeting tomorrow, because there's a lot of traffic going in and out. So
And give you a chance to do some math tomorrow.
that's
while you're
right.
at home.
And think about some math problems for us. We will be back here tomorrow, as we keep telling you. We're going to be back on Tuesday, Wednesday, Thursday. We're live. But get some math problems ready for us. Give us a call and such. We will be glad to work with you. Again, Gary Petco for Knox County Schools. Thanks for being with us today. Those of you who answered on Facebook, Sharon, Mark, Melody, Vicki, thank you so much. And my friends, you know where we are. You know how to find us. Come back again tomorrow. We'll see you then.